This is a demo for kexec and kdump. Let's first start with kexec. So we will check if already we have loaded a kexec kernel. No, it's not loaded, so let's load it. With -L, we can pass the VM Linux that we want to load, and init ID we can use to pass init.mfs, and then this reuse command line tells to use the same command line what we had used for the first kernel. Okay, so now we should see this that kexec kernel is loaded. Okay, so execute it. Okay, so now we are into the second kernel, and so similarly we can do a demo for the kdump, but for kdump first we need to make sure that we have a crash kernel memory available. So if we would have passed a crash kernel equal to size argument into the kernel command line, then first kernel has reserved this memory for the crash kernel. Now, of course, at this moment we won't have crash kernel loaded, so we can load it similar to the second kernel. So here, instead of -L, we need to use -P to load a crash kernel. We also say capture kernel to the crash kernel. So when we use -P, it loads a capture kernel, and now we can see that it's loaded. Okay, now we can simulate. We can actually do a kernel crash using the sysrq trigger method, but first we will have to enable that process kernel and sysrq. So we have enabled sysrq trigger method. Now we can trigger it. Okay, so we have to write C. So as soon as we have seen that the kernel crashed, it has loaded the capture kernel, which was it has executed the capture kernel, which was loaded using the -P command. Okay, so while this capture kernel loaded, it would have prepared a VM code, and that VM code has the dump of first kernel. Okay, so now one option is that we can copy this VM code directly to the disk, or we can analyze it here with the crash utility. Other option is that we can use this make dump file utility, which not only just copies, rather also compresses, or in fact filters many pages which are not helpful for debugging, like free pages, etc. So let's give this VM code as the input, and let's save output VM code somewhere here. Okay, so we can see that there was a reduction in the size of this make-dump file output. So of course it's around 31 MB, while the proc VM code was around 1.6 GB. Okay, so we could have analyzed it here, but let's reboot to another kernel, because most of the time we have done it manually, but normally this capture init.mfs are something where it will just copy automatically the proc VM code, and it will boot to another stable kernel where we can analyze the VM code later on. And to analyze the VM code, we need to use this crash command, and we need to pass this crash command VM code and VM Linux as well. Okay, and then this VM code. Okay, so this crash utility helps us to know that at which point kernel crashed and what was the memory content, what was the different task status at those points. So let's do some backtrace over here, and we can see here in the backtrace that the kernel has crashed at this program counter. So we can just see the code at this program counter, and here we can see that the code was trying to write 0x1 at location 0x0. So of course that's an invalid write operation to an address which is not actually existing. So that's why it crashed. Similarly, you can have many other commands over here that we can use, and we can have this manual for any of the command, and we can know what exactly that do. So like p2v, physical to virtual man, tells that how does it work. Okay, so that was all about kexec, kdump, and how we can analyze the dump.